In this one, we're selecting the correct electron configuration for an ion. So why don't you go ahead and take 10 more seconds on this second clicker question for our intro. Okay, so it looks like we have a little bit of a mixed consensus here. Let's go over this question. All right, I know there's a lot to talk about this competition, but let's just get into listening mode here and talk about how we can figure out what the correct electron configuration is for this ion. Remember, ions are a little bit different. The first thing we need to do is write the electron configuration for the atom itself, and then we need to take an electron away. So here we're talking about V plus 1. So if we were to write it just for the neutral electron itself, we would find that the electron configuration is argon. That's the filled shell in front of it. Then 4s2 and 3d3. So this would be for the actual filled, the completely neutral atom. But remember what we said, which was when we talked about this, is at the end of class on Friday, we said that it turns out that even though 3d is higher in energy when it's not filled, once we fill it with an electron, these two orbitals actually switch place in terms of energy. So if we were to write this in terms of energy, we would actually have to rewrite it as 3d3 and then 4s2. So which orbital would we take an electron out of if we were ionizing this atom here? The s. So we would actually take an electron out of the s, which gives us 3d3 and then 4s1. So it's a little bit of a trick when you're dealing with ions. The best suggestion is just to write it out completely for the neutral atom, and then you want to take an electron out of the highest orbital. It makes sense that it's going to come out of the highest occupied atomic orbital because that's going to be the lowest amount of energy that's required to actually eject an electron.